To talk about the equipment using liquid-liquid extraction, it is important to know what is the liquid-liquid extraction. Liquid-liquid extraction is a separation process consisting of the transfer of a solute from one solvent to another, the two solvents being immiscible or partially miscible with each other. Frequently, one of the solvents is water or an aqueous mixture, and the other is a non-polar organic liquid. As in all extraction process, liquid-liquid extraction comprises a step of mixing followed by a step of phase separation. Mixed settlers are simple stage-wise liquid-liquid extractors. As the name suggests, there are two stages involved: mixing and settling. In the mixing stage, the immiscible solvent and the solute carrying feed are brought into contact. Droplets are formed by the mixing, and the desired solutes are extracted by the solvent. In the settler, the two liquid components do just that. They settle out in two phases. The heavier phase exits out the bottom of the settler, and the lighter phase is done off the top. The mixed settler system shown here is used in chemical processing. The mixed settler system became quite popular in metal industry for their ability to handle high throughputs that require long residence time.
Spray towers. Spray column liquid-liquid extractors are the simplest of the column designs. The dispersed phase is introduced via a nozzle either at the top or the bottom of the column, depending on whether the heavy phase or light phase is being dispersed. The continuous phase enters the opposite end of the column, resulting in mass transfer through the vertical counterflow of the two phases. There is no dispersion coalescing cycle inside the column, resulting in very low efficiency for spray columns. Spray columns work best for fluids containing large suspended solids. The column is comprised of several perforated trays along with either downcomers or upcomers, depending on which phase, heavy or light, is chosen to be continuous. The original dispersion is performed by a nozzle, as in spray columns. Cross-flow contact occurs between each tray. Advantage: spray columns are inexpensive. Disadvantage: spray columns are very inefficient. Packet towers. In packet column liquid-liquid extractors, the packing, which assists in droplet formation, can either be structured in a mesh net or randomly placed in the column. Dispersion is accomplished with a nozzle at the top or bottom of the column, depending on whether the heavy or the light phase is being dispersed. As in sieve tray columns, the internals of the column need to be covered with the continuous phase. Advantage: packet columns are highly efficient when only a few stages are needed. Disadvantages: sieve tray and packet columns can suffer from solids plugging. Packet columns have lower throughput due to the packing. Packet columns are hard to scale up accurately. The initial dispersion is a concern for packet columns to avoid channeling.
Plate columns. The column is comprised of several perforated trays along with either downcomers or upcomers, depending on which phase, heavy or light. The original dispersion is performed by a nozzle, as in a spray column. Cross-flow contact occurs between each plate. Sieve tray columns are stage-wise contactors due to the coalescence of the dispersed phase between trade and its distribution through the perforation in the plate. Advantage: plate columns can handle a very sizable trackpad. Plate columns have a good success with scale-up producers. Disadvantage: columns can suffer from solid plugging. Columns with mechanically assisted agitation. Agitated column contains some type of mechanical device to agitate the liquid as they pass through the column. Rotating and reciprocating mechanism are the most common method for creating and maintaining dispersion throughout the column. Turbine impellers rotate between a set baffles, creating several mixing zones along the column length. The mixed liquids move to the outside sets of the stator baffles, where they can separate out and move up or down to the next stage. The heavy phase enters to the top of the extractor and mixes with light phase in the top mixing region, compose a rotating disc. The two phases then enter the external settling stage where they separate. Advantage: mechanical part result is a good dispersion. Little axial mixing compared to a non-agitated columns. Disadvantage: repair of internal mechanical parts can cause process delays.
Liquid extractor columns are used in several different industries, including the petrochemical and water desalting and purification industries.